This is the video solutions for topic 7 practice. Now the fill in the blanks for the H, T, V, and S, we already know them. It's on page 23 in our notes or the video notes from topic 7. H is the height, T is the time, V is the velocity, and S is the starting height. Now if you look at the first question, it says an apple is falling from a branch 9 feet above the ground. That is our starting height is 9, so S is equal to 9. Now because we see the word falls, there's no velocity behind it. There's nothing being thrown, no force, so we're going to have a velocity of 0 for this problem. Right, when we look at the equation, we've got h of t, or just h, is equal to negative 16t squared. Our velocity is 0, so we're going to plug that in. Our starting height is 9. So I erased the velocity because we don't need the 0 in there. It's just going to clear a little bit of things up when we try to factor. Now, because it says when does it hit the ground, that means h is equal to 0. So I'm going to plug in 0 for h. Now, at the same time, I'm just going to swap the order of my two terms only because I noticed they're both perfect squares, but they're not separated by a subtraction sign. But if I swap them, they are. Now I can use difference of squares factoring, since 9 is a perfect square and 16t squared is a perfect square. Square root of 9 is 3. Square root of 16t squared is 4t. We have opposite signs, and there we go. It is fully factored. All right, let's set each of those sets of parentheses equal to 0 and solve. So we get t is equal to 0.75 and negative 0.75. Since we can't have negative time, we'll throw away that negative 0.75 and keep 0.75. Final answer, 0.75 seconds. We need to include the word label because it is a word problem. All right, looking at number 2, we got the Easter Bunny jumping from the ground. If he's leaving from the ground, his initial height is 0. In this problem, we do get a velocity. The velocity is 64 feet per second, so that is our v. After how many seconds does the bunny hit the ground? That's our height of 0 once again. Let's plug in everything we know. 0 for height, 64 for v, and 0 for h, and again we don't need that. Alright, let's factor, but first let's take out the GCFs. 16 and 64 are both divisible by 64, and we can take out, are both divisible by 16, sorry, and we can also take out a t, leaving us t minus 4 in parentheses. Let's set each of those items equal to 0 and solve. Now, just like negative time, we don't need to use time when it's equal to 0, so we'll throw out that and keep the 4. Final answer, 4 seconds. Right, number 3, a baseball is hit at an initial height of 2 feet. So because it's in the initial height, our S value is 2. The velocity is 14, v equals 14. How long was it in the air before it reached the ground? Setting the height equal to 0. Plug it in. 0 for height, 14 for velocity, and 2 for S. Now in this problem, we do have a GCF, so we are going to divide everything by 2, and we can divide because it's an equation. So we get this, and only one thing wrong, we always want our t squared or x squared term to be positive, so I'm just going to change the sign of everything, which essentially means I'm multiplying everything in the equation by -1, or dividing by -1. Alright, we have a leading coefficient of 8, we've got to use the box method. Our magic number is -8, and the factors of -8 that add to -7 are 1 and -8. Plug them in. Factor out to the left, and factor out to the top. So we have our factors, put them in parentheses, and set them equal to 0. Now that we have satisfied the 0 product property, we can set t minus 1 equal to 0 and 8t plus 1 equal to 0. We have 2 solutions, but again, can't have negative time. Throw that one away, keep the 1. Final answer, 1 second. Very short amount of time. Number 4, an athlete throws a shot put with an initial velocity of 29 feet per second. That's our v. Initial height of 6 feet, there's our S value. After how many seconds will the shot put hit the ground? Looking for when the height is equal to 0. Okay, let's plug it in. 0 for height. Negative 16t squared will always stay that. Our velocity is 29, plug that in for v. And our starting height is 6, plug that in for S. Now in this one, we don't have a GCF, but I am going to divide everything by that -1 because I don't want a negative leading coefficient. So to save room, I'm just going to erase it and change the signs, just like I did in the first one. Box method time. First term and last term, magic number is negative 96. Now there's a lot of factors of negative 96. Just keep using your calculator till you find them, but they have to add to negative 29. That's going to be negative 32 and 3. Plug them in and factor out to the left and to the top. Remember, you can always double check this type of factoring by making sure it multiplies back out to what's inside. So put them in parentheses, set them equal to 0, and solve. We get two solutions. One's negative, throw it out, keep the positive. Answer, 2 seconds. Number 5, a small vegetable garden has an area of 80 square feet. Its length is 2 feet more than the width. Alright, so it doesn't say this, but it's supposed to say it's rectangular, so let's draw a rectangle. The length is 2 feet more than the width, so that means the width is just, we'll use W. The length is 2 feet more than that, so it's going to be W plus 2. Because it's a rectangle, opposite sides are equal. So now it says find the dimensions of the garden. The other piece of information was that the area was 80 square feet, and any area of a rectangle is length times width. So we're going to plug in 80 for area. And then our length is W plus 2, and our width is W. So multiply them together. Now, in order to use the zero product property, we have to have 0 on one side. So I'm gonna multiply on the right first, and then subtract over that 80. Again, that order doesn't matter, but we do have to have 0 on one side, and you do have to do the distributive property on the right to multiply. Luckily for this one, we don't have to use the box method because we have a W squared. There's no number in front of it, so we can go right to our double bubble. What multiplies a negative 80 but adds to positive 2? That's going to be positive 10 and negative 8. Let's set each of those equal to 0. We get two solutions. Negative 10, which doesn't make sense. You can't have a negative 10 width for your garden. The other solution is positive 8. That makes a little bit more sense. So I'm going to plug in 8 for the width. And that means when I plug it in for the length, it's just going to be 8 plus 2, which is 10. My dimensions are going to be 8 by 10 feet for my garden. Number 6, we're going to set it up the same exact way. This time it's a little easier because it says the length of the side is x plus 4 and the width is x plus 1. Alright, here we go. X plus 4 and x plus 1 for the width. We have an area of 40 square feet, so we're going to set it up the exact same way. 40 is the area, plug it in for area, and we've got length times width, x plus 4 times x plus 1. We are going to have to FOIL that right side. Combine like terms, and then finally subtract the 40 over because we have to have 0 on one side. Now, we don't have a leading coefficient. The leading coefficient's 1, so we can go right to the double bubble, what multiplies to negative 36 and adds to positive 5. That is going to be positive 9 and negative 4. Set them both equal to 0 and solve. We get x equals negative 9, but again, negative 9, even if we plug it in for x, we're going to get negative dimensions, so it doesn't make sense. However, x equals 4 totally makes sense, and let's plug it in for x, because that's not the answer to the question. The answer is find the dimensions. So we got 4 plus 1, which is 5, and 4 plus 4, which is 8, so our dimensions are 8 by 5 feet. Alright, only a few more. So the length of a rectangle exceeds its width by 4 inches. Find the dimension of the rectangle. If its area is 96 square inches, it's going to be like number 5. So let's go ahead and draw our rectangle. So we'll use W for width, and it says the length exceeds the width by 4 inches. That just means it's 4 more. So we're going to do W plus 4. Again, opposite sides are equal. Area is equal to length times width. The area is 96. That is given in the problem. Go ahead and use the distributive property on the right, and then we're going to end up subtracting 96 from that. Now we can factor right to the double bubble method because our leading coefficient's 1, or the W squared, doesn't have a number in front of it. What multiplies to negative 96 and adds to positive 4? That's going to be positive 12 and negative 8. Set them both equal to 0 and solve. Again, negative value for the width doesn't make sense. We'll keep W equals 8 because it's positive. Plug it in for W, and plug it in for W to solve for the length. 8 plus 4 gives me 12, so my dimensions are 8 by 12 inches. Number 8, the measure of one side of a square is increased by 2 centimeters, and the measure of the adjacent side is decreased by 2 centimeters. The area of the resulting rectangle is 32 square centimeters. So this is a little interesting. So let's go with one side of the square. All sides are equal. That went a little bit ahead of me, so I'm going to try to back it up a little bit. Here we go. Nope. You guys get the point. So all sides of the square are equal, so it's x, 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 x. Now it says we are increasing one side by x by 2, but decreasing the other side by 2 as well. So one side's x plus 2, the other side's x minus 2. It's no longer a square because the sides are different. So now we can use those sides, multiply them together, and set them equal to the area of 32 square centimeters. So x minus 2 times x plus 2 represents the area, which they gave us is 32. Just like the problem above it, or sorry, not the problem above it, number 6, we are going to have to FOIL because we don't have 0 on one side. So we got x squared plus 2x minus 4 equals 32. Combine our like terms in the middle, and they actually cancel each other out. Positive 2x and negative 2x will just cancel each other out. Subtract 32 from both sides. We get x squared minus 36 is equal to 0. This is our difference of squares factoring. There's no GCF, but we have a perfect square and a perfect square separated by a minus sign. So we look at square root of x squared and the square root of 36. So the square root of x squared is x. Square root of 36 is 6, and use opposite signs. Set them both equal to 0. We get negative 6 and positive 6 for our solutions. However, can't have a negative value, so we throw that out and keep the 6. So it says find the measure of one side of the square. So our square has just side x, so we don't need to plug 6 back in anywhere because the side of the square is x, and we just found out x is 6. Final answer, 6 centimeters. Alright, I hope this was helpful. I know the video is a little lengthy, but you can fast forward and rewind as much as you need to. Thank you for listening.